Back to Balvikan Bharti with the Vilas Sarkar. Before going to the next problem, that is problem number 34 in fluid statistics, I want to bring one point that I have ended with the 33 problem. There, the pressure required was the pressure. If you remember the problem I've gone through, it was said that what would be the ordinary pressure gauge reading at B. So what I have in 33, whatever I have calculated, the pressure at B is 1.59 into 10 to the power 5 Pascal, or equivalent to 1.59 or 1.01, that much bar you can calculate. But this was not the exact pressure. I just skip that part. This is the absolute pressure at B, but it has said that what is the gauge reading, because the gauge reading, if you have remember, it is nothing but absolute pressure minus the P atmospheric. So whatever reading you have find here, that has to be deducted with 1 into 10 to the power 5 Pascal, okay, or equivalent bar, whatever is coming. So if in case the problem comes in gauge pressure, so remember the gauge pressure will be the absolute pressure. Whatever I find here, it is the absolute pressure. Okay, but whereas gauge pressure, or what the reading it will show in the gauge, that means the gauge pressure. That's why it is named that gauge pressure, the pressure gauge. The pressure gauge shows the gauge pressure only. So gauge pressure there it is -1. The atmospheric pressure it is 1 to 10 to the power 5 Pascal, or 1 atta, or it is equal to 1 atta, or just equivalent 1.01 bar. So whatever, this much has to be deducted from the result. Okay. So I think I have missed out there, but before starting the next problem, I thought it would be better to continue with that. Okay, now going to the next problem, that is 34. For the system shown in figure, I will draw the figure after finishing this this problem statement. For the system shown in figure, the cylinder on the left, at L has a mass of 600 kg, has a mass of 600 kg, and a cross section area 25 centimeter square and negligible weight, okay. If the apparatus is filled, if the apparatus is filled with oil whose density is given as 0.78 gram per centimeter cube, find the force F required to hold the to hold to hold the system in equilibrium as shown. Okay, let me show you the picture. This is an arrangement apparatus, you can say. Well, this is have two leg. One is a bigger cross section, other one is smaller cross section. There is a piston on which a load is kept. This load is of 600 kg mass. On the other hand, there is another piston on which a force F is being applied, due to which the dimension whatever is given here this is said to be this one is said to be 8 meter. As this is an H1, it must be H1 because we are taking the same horizontal line. F is the force, and let me read it out. This is the diagram. If anything left, I will draw it again. For the system shown in the figure, the cylinder on the left side at L has a mass on the left at L. Let this be pointed as L. This point, this horizontal line is taken as a L. Okay. The mass of 600 kg and a cross section of, so the mass is 600 kg. So then weight is equal to mass into acceleration. This is in kg. So if I take acceleration in SI, so this will be 600 into 10 I am taking. So this will be in Newton. Okay. So I am considering, and the cross section is given as 25 centimeters square. So that I will convert into meter square with 10 to the power 4 meter square. I am converting everything in SI. Fine. And the negligible weight of the piston. This piston itself have no weight. This is not putting any additional weight apart from this 600 kg of mass. Okay, so this has only the force is coming due to this is this one. Okay. If the apparatus is filled with an oil, this is filled with oil whose specific gravity or density you can say 0.78 gram per centimeter cube. So that has to be converted into SI unit by 10 to the power 3 kg per meter cube. This conversion you will know well. Find the force F required to hold. So this total thing is in equilibrium as nothing is moving up and down. So what is the force balance here? At this point the horizontal line, if I take both are having at h1 height, so if it is L, this is let's say some other point S, so the pressure as L is equal to pressure at S is definitely S. So the pressure as at L, now these are both are end are open, so the effect of the atmospheric pressure we can nullify because both will be equally applicable. So what is the force is only PL, it is due to the, if at this datum if I say this is weight upon the cross section, and what is the force here, what is the pressure here, the pressure coming due to the force F with the cross section here. Now this cross section is not given. If the apparatus filled with the water and the what force. Now the system is in equilibrium. The left L has a 600 kg cross section of this is negligible weight. Whether the filled with the other and the force required to hold the system in equilibrium. So this force, whereas this cross section is not given. This is the cross section is not given. Now this is 8 meter and this is 25 centimeters the cross section here. This cross section is not given. How come? Now any cross section here, it will be divided by this, the pressure. If I balance it, this force divided by cross section plus the H rho G. H means 8 meter. Okay, now force, as I have taken in SI unit here, this also will come. So we will consider this cross section will be in meter square something, and this also in Newton. Okay, and the force due to this liquid column, H into rho is your this into 10 to the power 3 rho, and G also will take in SI unit. So this will be the case. So if I with that if I go in calculation, W was there 606 into 10 to the power 3, because 600 into 10, that was the weight, and area was 25 there in 10 to the power 4, that means it will go up 10 to the power 4. Okay, 25 is there. This is equal to F by A. At present, if I assume that there is no data is given, but anyhow, I think I have mistaken to draw that dimension is given. It could be probably by seeing my handwriting, it has given it as something. If it is pi r square is 25, so the r square, that means is equal to 25 into 7 by 22 round. So r will be 5 in root 7 by 22. So the value of A, it must be needed, because without that I cannot calculate the force here. I can get the pressure here, but the force to hold the system in equilibrium, it must have some cross section given. Okay, so then if I calculate this, 8 into 17 10 to the power 4, 0.7, if I multiply with this, 78, almost if I take approximation with 0.8, so it will be 64. I am taking approximation. This is equivalent to 0.8. 0.8 into 8 is equal to 64. 0.6 8 8 is 64. 64 then 6.4 will there, and to 10 to the power 4. Okay, so this 8 will move from here. So this is 6. So that means if I less 1 and make it 10 5 here, so this will be 424 into 10 to the power 5 is equal to F by A plus 6.4 or 0.64 if I take rather 10 to the power 5. So F by A is equal to 24 minus 0.64, this one, this equals 36, 23, 23.36 into 10 to the power 5, this much of Pascal. Now force, if you have to calculate, A must be known, but unfortunately I might have forgot or they might have forgot to give it. Without that I will get only the pressure, but pressure multiplied by the cross section will give you the force applied, force required to balance this. So this will be the process of doing that, but it must be there. Sorry that I forget this data to collect from the sum. So anyhow, if A is there, so you definitely know what you have to do, or what you have to do rather. So this will be in Pascal. Okay, force into, then if you multiply cross section, so the Pascal is Newton per meter square and it will be in meter square again, so you will get it something in Newton. So this much force is needed to keep it in equilibrium. Okay, so I'll move to the next problem. Next is 35. 35 says compare the pressure at 3 feet and 30 feet below the surface of fresh water to the atmosphere pressure. Okay, so this is the requirement. So this is a very basic problem, but still, as it is in FPS system, so this needs some conversion factor or with SI units or CGS unit, that will I will show you here. So this is something, water level on the surface, from there this may be 3 feet and it not to scale, it is 30 feet, let's say. Okay, so these are the and here on the surface it is atmospheric pressure. So I have to consider, let's say this is P1, this is P2. You have to consider P1 against atmospheric pressure. That means you have to calculate what would the value this and what is the value this. So then only we can compare the things together. Okay. So if this is the case, so basically I need not to be worried because this is anyhow be deducted. So what is this value all about? This is something you are getting gauge pressure, P gauge of that point, isn't it? Because you are deducting the atmospheric pressure, so you need to have the gauge pressure there. Okay, so what is the pressure? If I say the Pg1, that depends on only the H rho G. This is the case. So now one by one I will say what are the case. So even if you have to convert into SI units, or you have to get in FPS, both we will say. So what are the things? This is already there in 3 feet. Okay, so 3 feet means h. If I am to convert it 3 feet, that is equal to multiplied with 12. That will give you 36 inch. Okay, what is rho? Rho, as you know, in this is known value in, if I CGS, if I say this is 1 gram per centimeter cube. Now convert it 1 gram to now uh, 1 pound, which is in FPS, equal to 453.6 gram. 1 pound is equal to 453.6.5. This one, and 1 inch, that is in FPS, is equal to 2.54 of centimeter. So these are the conversion factor. Now if convert is this 1 gram is equal to 1 upon 453.6, this much of pound, and divided by 1 centimeter is equal to what? 1 centimeter is equal to 1 upon 2.54 of inch. So we have to convert 1 by 2.54, that whole cube of inch cube. So if I convert, this will go up to 2.54 whole cube divided by 453.6. This is pound per inch square. So this is your rho. Okay, this is converted. And what is G there? So what is G here? G, as you know, is in CGS is equal to 981 centimeter per second square. Okay, now second is an FPS also second. Only thing is this has to be changed. So what I have found, that has to be divided with 54. That will convert into inch per second square. So this will be put for first case. If I take this is equal to h, so that means is equal to 3 into 12, that is converted into inch, and rho is already there, 2.54 whole cube by 453.6 into this one G, 981 divided by 2.54. Okay, so one thing will deduct. Now apart from this, if I take approximation, this is around 1000 and this is 450, this is 2.54, approximate value by taking the round off. So this is 2.5 whole square divided by, and this is 1000 10 to the power 3, and this is 450. So this will ease your calculation. So so what is the value? 36 into 2.5 means 6.25. Okay, and this is equal to 10 to the power cube. This is equal to 450. Okay, so now this also again be can reduce 425, 25 2, 25 5, 25 1. How much? In 100 it is 4 times 400, 416 times plus 2, 16, 18. Okay, this will be 36 2, and this will be 50 into 2, that means it's equal to 5 into 10 to the power 2 pound per, and this is pressure. Whatever I am getting, this is pressure. So this is pound per inch square. Load poundal per inch square. This will be the case. So this is PG1, and second one, this is instead of 3, it will be 30 feet. So this will be 10 times. PT2 is equal to 10 times. So 10 into 5 into square. So that means 5 into 10 to the power cube, and unit will be same in square. Okay, in FPS. You can convert into, if it is in SI unit, convert all the units accordingly. Okay, and get the answer. Fine. So here I will stop this session. In the next session I will move on to the problem number 36. That will be an application problem. So I am not continuing in this. so that that session can be taken separately, because that needs time to make you understand. So I'm stopping this part. So this is, and then after we'll start the application problem. Okay, so thank you for now.